Most people with brown eyes have spent their entire lives being told they have the most boring eye color on Earth. Bland, basic, the default setting. And that narrative is completely wrong, because brown is not one thing. Brown eyes are not a category. They are a spectrum of 7 genetically distinct types, each one shaped by a different ancestral journey, each one carrying its own hidden biological advantages and real, measurable disadvantages. And by the end of this video, you're going to look at your own eyes in the mirror and see something you have never seen before. Let's start with the most dramatic on the list, the amber eye. People throw this word around constantly and almost always incorrectly. True amber is not hazel. Hazel breaks up into rings and patches of color. True amber is a solid, uniform, golden copper tone that does not shift, does not waver, and does not change with lighting. How does nature produce that? It comes down to a near total dominance of pheomelanin, the yellow-red pigment with almost zero eumelanin, the brown pigment, layered on top. The stroma of the iris is essentially cleared of the dark pigment that clouds most brown eyes, leaving behind that pure metallic gold. Researchers believe this variation survived through small, isolated European populations over thousands of years. If you have true amber eyes, you are statistically one of the rarest humans alive when it comes to eye pigmentation. The advantage is evolutionary distinction. In the animal world, amber is the color of the apex predator: wolves, eagles, owls. While humans obviously lack the night vision hardware of a wolf, the visual impression this color makes on other humans is measurable. Studies on facial perception show that solid amber eyes register as more intense and commanding than warm brown shades. That social gravity is real. The disadvantage is the same coin flipped over. That intensity can read as intimidating or unreadable. Where soft espresso brown feels, warm and approachable solid amber can make people feel like they are being watched rather than seen. Next, the ash brown, which some researchers call the slate brown. And it is visually one of the most confusing eyes on this list. It looks like a standard brown eye viewed through a gray filter. The warmth has been drained out. The reds and yellows are muted. What you are looking at is the Tyndall effect operating deep within the iris. The melanin in ash brown eyes sits lower in the stroma than usual, while the outer layers carry more collagen interference. Light has to pass through a cloudier medium before bouncing back out, and that journey strips away the warm wavelengths, leaving a cool, steel-toned brown at the surface. You find this pattern most often in populations with deeply mixed ancestry: Eastern Europe, the Middle East, Central Asia, where light eye genes and dark eye genes have been blending for generations. The hidden advantage here is neutrality. This color does not clash. It does not compete with skin tone or hair color. It blends into almost any look, which makes it one of the most versatile eye colors aesthetically. The disadvantage is that cameras hate it. In photographs, ash brown eyes can appear flat and featureless because they do not reflect the warm spectrum. This is a color that requires physical proximity to appreciate fully. On a screen, it disappears. Now things get genetically interesting. The cognac shade, also called chestnut. Have you ever caught your brown eyes in bright sunlight and noticed they look almost reddish or coppery, like the inside of a polished coin? That is not a lighting trick. That is pheomelanin crashing the genetics. In cognac eyes, the blueprint calls for a normal amount of eumelanin, but a mutation spike pushes the red pigment production higher than standard. And geneticists have traced this to the MC1R gene family, the same gene cluster responsible for red hair and freckles. You do not need to be a redhead to have cognac eyes. But somewhere in your family tree, an ancestor carried those fiery traits, and you are carrying the echo. The biological advantage here is subtle but real. The same genetic pathway that creates those reddish tones is often linked to skin types that produce vitamin D more efficiently under low-light conditions. Your ancestors likely migrated away from the equator, and your eye color is a biological timestamp of that journey. The disadvantage is UV sensitivity. Because you carry less dense eumelanin than your darkest-eyed relatives, you have less built-in solar protection. You are not working with maximum sunglasses. You need to be more deliberate about eye protection in strong sunlight than people with obsidian or espresso eyes. Moving lower on the melanin volume dial, we arrive at honey brown. And this is where physics completely takes over from biology. Honey and russet eyes are a product of something called light scattering within the iris stroma. When melanin levels drop to the middle range, the stroma becomes partially translucent. Light enters, hits the collagen fibers, and scatters. In honey brown eyes, you have a very specific balance. Enough melanin to produce a yellow-brown base combined with just enough blue scatter from the collagen to create that golden, almost metallic shimmer. It is literally the same optical process that makes the sky blue, happening inside your eye. Yellow pigment plus scattered blue wavelengths equals liquid gold. The advantage is what makes this shade spectacular. Because it depends on light scattering, it is extraordinarily responsive to the environment. In a dim room, honey eyes look standard brown. Step into direct sunlight and the scattering fires up, igniting them into a glowing amber gold. You have a biological dimmer switch in your iris. The disadvantage is photophobia, light sensitivity. With less melanin absorption happening, more light gets through to the retina than your eyes were designed to. Handle comfortably. Bright, overcast skies, the kind that feel like staring at a giant white screen, can be genuinely uncomfortable. Something people with obsidian eyes never think about. Now the obsidian brown. This is the heavy artillery, often mistaken for black eyes, and that is actually impossible because true black eyes do not exist in humans. What you are seeing when you look at someone whose iris appears completely black is an obsidian brown, where the concentration of eumelanin is so dense that it absorbs close to 99% of the incoming light. There is no scattering, there is no reflection. The stroma is saturated so completely that the eye appears to have no color at all, just depth. This is not a flaw. This is evolution's original blueprint for eyes, engineered in the highest UV radiation environments on Earth to function as high-performance biological sunglasses. The performance advantage here is significant. People with obsidian eyes struggle less with glare and maintain sharper visual clarity in intensely bright conditions compared to lighter-eyed individuals. And there is a more surprising finding. Some research has explored a correlation between high melanin pigmentation and faster reactive motor processing, potentially linked to the neural transmission properties associated with melanin production in the brain. The disadvantage is one you might not expect. A preliminary study suggested a link between genes driving maximum dark pigmentation and a slightly lower tolerance for physical pain. You react faster, but when something hits, you feel it more completely. Step down slightly from obsidian, and you reach espresso brown, the most common variant of all. But common does not mean simple, because at this density level, the melanin is not quite wall-to-wall, and that gap reveals something remarkable. You can start to see the actual topography of the iris, the craters, the furrow lines, the depth structure of the stroma beneath. These are not imperfections. They are windows into the eye's architecture, and under the right light, espresso eyes have more visible complexity than almost any shade on this list. There is also a surprising physiological finding attached to this type. Research from Georgia State University found that people with classic dark brown eyes show a higher biological sensitivity to alcohol, becoming affected faster than lighter-eyed individuals. At first, that sounds like a disadvantage, but the data tells a different story. Because the body signals enough earlier, dark brown-eyed populations statistically show lower rates of alcohol dependency. The biology builds in a natural break. The disadvantage is purely visual. In flat indoor lighting, espresso eyes can look one-dimensional, masking all that internal texture and depth that makes them so striking when the light actually hits them correctly. Finally, we arrive at the Starburst, and this one is in a category of its own because it is not really about color. It is about pattern. You know this eye if you have it, because your entire life people have stopped mid-conversation to say, "Wait, what color are your eyes actually?" You look closely and you see a dense ring of dark chocolate or near black melanin packed tightly around the pupil. Then radiating outward, the melanin thins and explodes into streaks of gold, green, or amber before settling back into brown toward the outer edge. It looks like a solar flare frozen inside your iris. This is a form of central heterochromia. During development in the womb, the melanocytes that produce pigment run out of fuel as the iris expands outward. They saturate the center with full-density pigment, then trail off as the iris grows larger, leaving that layered burst effect behind. The advantage is neurological. The human brain is wired to detect contrast and track it. The bullseye pattern of starburst eyes creates an involuntary focal point. When you make eye contact, the person across from you is being pulled toward your pupil by their own visual processing system. Your eye contact registers as significantly more intense and memorable than a solid eye color. The disadvantage is the confusion. You will never get a straight answer about your eye color for as long as you live. Documents that ask for eye color will cause you a minor identity crisis, and you will spend years explaining to people that yes, they are technically brown, but also sort of gold, but also sometimes green. So here is the bottom line. Every single one of these 7 types traces back to one gene on chromosome 15, a gene called HERC. 2 functions like a volume knob on melanin production. Turn the dial to maximum and you get Obsidian. Ease it back slightly and you get Espresso. Keep pulling it down and you pass through Cognac, honey, ash brown, amber, and into the Starburst territory where pigment delivery ran out of time. You were not handed a boring eye color, you were handed a biological archive. Your specific shade tells a story about where your ancestors came from, what latitudes they survived, and what genetic hands were folded together over thousands of years to produce the exact iris pattern that exists in you and no one else. So go find a mirror, use a flashlight, get close, and figure out which of these 7 is actually looking back at you. Then come down to the comments and tell me your type. I read every single one. And if this changed how you see your own eyes, hit that like button because it helps more people discover something remarkable about themselves.